Hi, my name is Mercado. I am a student at the University of Alabama in Huntsville. I was a part of the RCEU program this summer there, where I did a research project, and that research project was titled Lewis-1WR1 rats show an increased risk of developing malignant forms of NAFLD. Hopefully, at the end of this presentation, I will have told you a little bit more about my research and the conclusion of my research. This project looked at a specific type of rat called the Lewis-1WR1 rat. It's a rat that is special because it overexpresses a gene called FAT10. That FAT10 is a type 1 diabetes susceptibility gene and a gene that may play a role in inflammation, adiposity, cancer, and kidney disease. We've studied that gene in the past, and we know that this rat model, when exposed to a moderate sucrose diet, will also develop glucose intolerance. Past studies that we've done focused on FAT10's effects in the pancreas and insulin production. And in those studies, when we harvested the rats, we harvested all their organs and we did qPCR. And we found that the liver had a high accumulation of FAT10 protein. We wanted to see what that FAT10 did in the liver, just like how we looked at the pancreas. We wanted to look at the liver now. And so non-alcoholic fatty liver disease, it's a blanket term for a variety of conditions that affect the liver, that liver being or having an overaccumulation of fat in it. And so the first and most common form of it is steatosis. Steatosis is basically an accumulation of lipid droplets in the liver cells or fat in liver cells. And so this is benign and can be reversible back to a normal healthy liver, but it can also progress into a more malignant form like steatohepatitis, which can lead to inflammation, cell death, and formation of scar tissue, fibrosis, and then eventually more severe fibrosis, cirrhosis, and then that can eventually lead to liver failure or liver cancer as well. And so in order to gauge progression of NAFLD, there was a paper in 2005 outlining a scoring system called the NAFLD activity score, which is used to kind of predict progression of NAFLD severity, which is what I did this summer on these livers that we extracted. We had a control rat, the Worcester Firth NHSD rat, and we had the Lewis-1WR rats that we're interested in. We gave them two different diets, the 10% kilocalorie fat diet that had 7% sucrose, and the 10% kilocalorie fat diet that did not have 7% sucrose. Again, I mentioned in response to a moderate sucrose diet, these 1WR rats will develop glucose intolerance, which was one of the factors that we wanted to look at and how it affected the liver. And so at the end of the 18-week study, we took the livers out, we weighed them, and we formally fixed them and sent them to a company called HistoWiz. HistoWiz takes samples from researchers, they'll stain them and digitally upload them to their website, and then using that, researchers can analyze them. And so we sent them our livers, they hemotoxin and eosin stained them, which is basically staining the cell nuclei pink, purple actually, and the cell cytoplasm pink. And so following the guidelines set in the paper that I talked about, design and validation of a histological scoring system for non-alcoholic fatty liver disease, we gave them a NAS score. So statistical analysis was done on those scores, ANOVAs were done, and then you'll see later significance was denoted by different letters. Liver masses. We weighed the livers, like I said, and we found that the 1WR rats had heavier livers than the Worcester Firth rats. This correlates to later on, I'll talk about the steatosis. They had more steatosis, they had more fat in their livers, which is why their livers were heavier. This also correlates to glucose intolerance, how their body wasn't able to get rid of the glucose in the bloodstream, and that glucose is probably converted into more fat in the liver. The first factor of NAS, liver ballooning, we saw fairly even scores and no significant differences between either of the rat groups and either of the diets. Liver ballooning is a factor used in describing steatohepatitis as an early indicator of cell degeneration or cell death. The scale of it is from 0 to 2, and so 0 being none, 1 being few, and 2 being many. And so I want to point out that as a possible factor for these even scores is that the scoring system doesn't differentiate between maybe an earlier characteristic um, liver ballooning versus a later stage liver ballooning. And so here, this example of liver ballooning that I added on, this is a 1WR1 rat with pretty extensive liver ballooning, very clearly the hepatocytes nuclei is in the middle, and then you have all this space ballooned out with wispy parts of cytoplasm left over. And so this is probably more later liver ballooning, but I believe some of the Worcester-Firth rats had more subtle liver ballooning. And so those were kind of more early stage liver ballooning, which wouldn't get differentiated by the scoring system. Steatosis. Steatosis, we saw that the 1WR1 MS diet had significantly different steatosis rate than all the other rats. Also, the Worcester-Firth MS diet and the 1WR1 control diet showed a mirrored score that was higher than the Worcester-Firth control rat, although it wasn't significantly different. Basically, what I want to point out here, much like in the liver ballooning, is that the scoring system was kind of attributed to this lack of differentiation between the 1WR1 rats and the Worcester-Firth rats. The scoring system goes from 0 to 3, 0 being less than 5%, 1 being 5% to 33%, 2 being 33%, 66%, and then 3 being 66 to 99%. And what I saw when I scored the slides was that a lot of the 1WR1 rats had a more leaning towards a 99% steatosis rate, a really high steatosis rate, where there was a lot of accumulation of these lipid droplets, fat droplets in their liver slides, versus the Worcester-Firth rats, which still might have gotten a 3, but were more pointed towards the 66, the lower end of that 3 score. And so that's important to note because the 66% steatosis rate, while still pretty severe, is not as severe as a 99% steatosis rate. Those show different levels of NAFLD progression there. A 99% steatosis rate will progress faster into the more malignant forms, steatohepatitis, cirrhosis, eventually, liver failure. And so that lack of differentiation between 99% and 66% is important to note. The last NAS factor is inflammatory foci. This is these small purple focal points. It's basically the inflammation in the cell. And so these, we saw that the Worcester-Firth control was significantly different to the 1WR1 control, but that other than that, all the other rat groups were not significant to each other. This was graded on a scale of 0 to 3, 0 being none, 1 being less than 2 foci per 20 times field, 2 being 2 to 4 foci per 20 times field, and 3 being more than 4 foci per 20 times field. There was more inflammation along the edges of the liver and around certain blood veins of the liver. And basically, what accounted for probably this score, these scores, was that in the 1WR1 rats, in a lot of the slides, a lot of the middle portion of the liver was different in that it had a different coloration and that it was not stained pink like the normal Worcester-Firth rats were. They had a kind of a discoloration, and this is predicted, or what we predicted to be like fibrosis, and that could have accounted for the lower Lewis 1WR1 scores because these rats were already kind of past the inflammation stage, and they were their cells were more dying, like, and the inflammation was going away, and the fibrosis was starting. And so yeah. Finally, that steatosis, liver ballooning, and inflammatory foci were all added up into a NAS score. And so basically, you saw significant difference between the 1WR1 MS diet to the 1WR1 control, and no other significant difference. As I said, this is an aggregate of all those 3 factors that I talked about. And it's also an aggregate of all the problems that I talked about, the problems between the early and later liver ballooning characteristics, the problem between the 66% steatosis and the 99% steatosis, the problem between the fibrosis that was in the slides, or the predicted fibrosis. And so that all those problems accumulated. Um, um, all those problems led to the scoring, and then the scorings were added here. So this is probably why the scoring is a bit even overall. Basically, the conclusion of this study. Conclusion, we had a couple different conclusions. The diet of moderate sucrose affected the liver fat development much higher in the Lewis-1WR1 rats than the Worcester-Firth rats. This could be that the FAT10 increases sensitivity to the sucrose diet. The Lewis-1WR1 rats showed a higher steatosis rate and liver weight than the Worcester-Firth rats. This is our main takeaway, because basically what it means is that the FAT10's role in the liver glucose intolerance, it may increase steatosis development and shortening time for future steatohepatitis and liver failure risk. A 99, like I said, a 99% steatosis liver will progress faster into steatohepatitis and eventually into fibrosis, cirrhosis, liver failure. And so basically that FAT10 will shorten the time it takes for that steatosis to develop, and shorten the time for steatohepatitis to develop in turn. And so future ways we can look at, we can continue this study are that predicted fibrosis, the discoloration we saw on some of the slides of the 1WR rats. We can mass on trichrome stain them to see their fibrosis levels specifically. And so that is a future direction we can take. And that is it for my study. Thank you for listening.